by the Flight Training Center, United Airlines. To provide the necessary alternating current for the DC-6 aircraft, two direct current-driven rotary inverters are installed to furnish 115-volt AC, 400-cycle, three-phase power. A small vibrator-type inverter furnishes 110-volt AC, 60-cycle, single-phase current with sufficient power to operate 5 electric razors. The AC electrical system of the DC-6 varies slightly between the Group 1 and Group 2 aircraft, as does the DC system. We will discuss the Group 1 AC electrical system and incorporate the changes in the Group 2 system later in this presentation. Alternating current is required in the DC-6 for the operation of the radios, the automatic pilot, certain instruments, and some lighting equipment. These items require approximately 1200 watts of 115-volt AC three-phase power for their operation. The single-phase 60-cycle 110-volt AC from the Razor inverter produces approximately 80 watts of power necessary to operate the electric shaver for the Blue Room receptacles only. The rotary inverters are located behind the radio rack and are mounted one on top the other, thus the name, the upper and lower inverter. The Razor inverter is located to the left and slightly above the upper inverter. Access to the inverters can be obtained by removing a panel on the rear left side of the radio rack. The rotary inverters are identical, self-contained units, capable of providing the required AC power for the aircraft. The inverter is simply a direct current motor turning an alternator or AC generator on a common shaft. As a self-contained unit, the inverter maintains a regulated frequency and AC voltage output, contains the necessary filtering devices to eliminate radio interference, and limits its current consumption during starting. Each inverter is capable of furnishing 2500 volt amperes of power when operating from 27.5 volts DC. The total aircraft AC requirements are approximately 900 to 1300 volt amperes, so each inverter has a capacity well above the total aircraft requirements. 3 switches in the cockpit, located on the center overhead instrument panel, provide control over the inverters. Each switch is a 3-position switch, with the center position being off. Any of the switches, when placed in either the upper or lower position, is capable of starting the selected inverter. The switches also distribute the output of the inverter to the AC-operated equipment in the aircraft. Simply stated, the inverter switches provide on-off control over the inverters and distribution of its AC output to the designated equipment in the aircraft. Located on the generator panel above the first officer's sliding window, the AC voltmeter and an associated selector switch is provided to monitor the AC voltage output of the inverters. The voltage furnished to the captain's and first officer's flight instruments, and voltage necessary to operate certain engine instruments. The normal position of the selector switch is the vertical position, or 26-volt AC engine instrument position. 2 red inverter warning lights are located to the left of the captain's and first officer's airspeed indicator to warn the crew of AC power failure to certain gyro-driven flight instruments. They are designed to warn the crew that the gyros are no longer reliable and should not be depended upon. Power to operate the inverters is provided from the master bus through 2 inverter circuit breakers. When either the captain's engine or first officer's inverter selector switch, is placed in either the upper or lower position, the switch provides a ground for the starting relay, which, when energized, allows 27.5 volts of DC power from the master bus to run the DC motor of the inverter. Any of the switches are capable of starting either inverter. In the example shown, the engine inverter switch is placed in the lower position and has started the lower inverter. The first officer's inverter switch, placed in the upper position, has started the upper inverter. Other sections or contacts on these same switches will also distribute the AC output of the inverters to selected equipment, as we will see later. The output of the alternator on the AC generator section of the inverter provides 115 volt AC 3-phase 400 cycle current. The phases are lettered A, B, and C. In the DC-6 aircraft, B phase is grounded to the aircraft structure. By utilizing connections from A to B, C to B, or A to C, we can obtain 3-phase or single-phase AC power as desired. AC equipment in the aircraft uses both single and 3-phase AC power. The A phase of both inverters is a regulated phase and is the voltage read in the cockpit on the AC voltmeter when the inverter voltage is selected. To simplify the inverter output distribution, we will use a block flow diagram, using a single line to represent all phases. 115 volt AC 3-phase power from each inverter is fed to circuit breakers located on the throttle lock relay box. These circuit breakers, called phase breakers, one for A phase and one for C phase, protects the inverter output in case of a short or malfunction. There are 4 phase breakers on the throttle lock relay box, 2 for each inverter. The throttle lock relay box is located to the left and behind the captain's seat on the bulkhead. 4 of the circuit breakers on this box protect the A and C phase output of the upper and lower inverters. The 5th circuit breaker is for the emergency instrument lights, discussed in the DC electrical presentation. AC power from the inverters goes through the phase breakers on the throttle lock relay box and is made available to the captain's flight instruments through the captain's inverter switch. The captain's turn and bank indicator and the gyro in the flux gate compass are 26 volt AC instruments. The 115 volt AC is stepped down to 26 volts AC through 2 26 volt AC flight instrument transformers. 2 fuses upstream of each transformer protects these items. 2 fuses in the output section of the transformers will provide protection for the flight instruments. 115 volt AC power stepped down to 26 volt AC through the use of transformers provide the necessary power to operate the gyros only in the turn and bank indicator and the flux gate compass. AC power to operate other functions in the flux gate compass is made available from power to the AC radio section. 2 26 volt AC step-down transformers are located on the right side panel of the main junction box to provide the required power for the flight instruments. The transformers are 3-phase input and output and are each protected by a pair of fuses called Captain's Flight Instrument Transformer fuses. The output of the transformers are fused in a comparable manner to protect the flight instruments. These fuses are referred to as the Captain's Flight Instrument fuses. The captain's flight instrument transformer fuses and flight instrument fuses are located in the AC fuse panel on the left side of the main circuit breaker panel. When facing the panel, the fuses are labeled and their functions listed on a placard on the outside of the door. The fuses are mounted in rubber blocks with a spare fuse. The AC fuse panel contains fuses for the captain's, first officer, and engine instruments, and for AC radio feeds, pressurization, and some miscellaneous AC requirements. Prior to the 26-volt AC step-down transformer, 115-volt AC is taken off to supply power to the automatic section of the cabin pressure control system, certain radio equipment in the radio rack area, and for fluorescent lights in the blue room. Fuses to protect the cabin pressurization and lighting system are located in the AC fuse panel. The majority of the AC fuses to protect the various AC sections of the radio equipment are located on the aft post of the radio equipment rack. AC fuse protection is provided for individual items of radio equipment that require AC power. The fuses for these items are located on a panel of fuse holders on the lower left side post of the radio rack. Directly above this panel is located a row of circuit breakers for the DC power required for certain individual items of radio equipment. An inverter warning light is installed after the flight instrument fuses to warn the captain that the gyro in his flight instrument, the turn and bank, is unreliable. It does not necessarily mean that an inverter has failed, as the light will illuminate if either of the phase breakers are tripped, or any one of 4 instrument fuses are blown, or even if the step-down transformer fails. Basically, all it tells you is that power to the turn and bank indicator has been interrupted. The captain's inverter warning light is located immediately to the left of his airspeed indicator. The light contains 2 parallel wired light bulbs that receive DC power from the inverter warning light circuit breaker on the main circuit breaker panel. The light will illuminate when power to the captain's turn and bank indicator fails. AC output to the first officer's flight instruments is almost identical to that of the captain's, with the exception that the first officer's gyro horizon is powered by 115-volt AC rather than 26-volt AC, thereby eliminating the need for a step-down transformer for that unit. As in the captain's case, 115-volt AC is taken off to power the flux gate compass gyro and certain radio equipment, in addition to supplying AC power for the autopilot. The turn and bank indicator is 26-volt AC, powered through a step-down transformer. Fuses to protect the transformer and the turn and bank indicator are located in the AC fuse panel, as were the fuses for the captain's equipment. The gyro horizon is 115-volt AC powered and does not require a step-down transformer. It is electrically protected by the same fuses that protect the 26-volt AC step-down transformer for the turn and bank indicator. The first officer's single 26-volt AC step-down transformer is located adjacent to the 2 26-volt AC step-down transformers for the captain's flight instruments on the right side panel, inside the main junction box. The 2 fuses to protect this transformer and the gyro horizon, as well as the 2 fuses to protect the turn and bank indicator, are located in the AC fuse panel. 115-volt AC power for the PB-10 autopilot, highlighted here in yellow, is furnished through the first officer's inverter switch, through fuses in the AC fuse panel, to the autopilot equipment located in the radio rack. It should be noted that interruption of power to the first officer's flight instruments could affect the operation of the autopilot. The first officer's inverter warning light, located immediately to the left of his airspeed indicator, performs in the same manner as the captain's inverter warning light. It will indicate, when illuminated, that insufficient power is being furnished to the gyro in his turn and bank indicator. 26-volt AC power is required to operate certain engine and heater instrumentation. This power is taken from the inverters through two 26-volt AC step-down transformers called engine instrument transformers. The transformers are always associated with an individual inverter, so they are referred to as the upper or lower engine instrument transformer. Power for these transformers is taken off the inverters prior to the phase breakers and are each protected by a fuse, referred to as the upper or lower engine instrument transformer fuse. The fuses for the engine instrument transformers are located in fuse holders on the throttle lock relay box and are here shown as the two outside fuses. A spare fuse, shown here in the center, is also located on the throttle lock relay box in a similar fuse holder. The throttle lock relay box is located on the bulkhead to the left and behind the captain's seat. 26-volt AC power from these engine instrument transformers can be selected by the engine inverter switch and directed to certain engine and heater Magnuson type instruments. Groups of instruments are protected by fuses located in the AC fuse panel. The first 5 fuses on the AC fuse panel protect the engine Magnuson instruments and cockpit instruments to monitor heater fuel pressures. Fuses numbered 1 through 4 protect engine instruments associated with the 4 engines, and number 5 fuse with the heater fuel pressures. The engine instrument fuses provide protection for the basic group of engine Magnuson instruments. In this case, number 3 engine instrument fuse provides protection for the BMEP, fuel pressure, fuel flow, oil pressure, and oil quantity indications associated with number 3 engine. Numbers 1 and 4 engine instrument fuses will provide protection for the same group of engine instruments as number 3 fuse, and in addition will protect the supercharger oil pressure indicator associated with each outboard engine. Number 2 engine instrument fuse provides protection for the number 2 engine instrument, the same as number 3 engine, and in addition provides protection for the flat position indicator. Number 5 fuse located in the AC fuse panel provides protection for the cabin, tail, left and right wing heater fuel pressure indicators, and for the mixing valve position indicator located on the stewardess panel in the buffet area. This fuse is located adjacent to the 4 engine instrument fuses, but is simply referred to as number 5 fuse. An AC voltmeter and an associated selector switch on the lower left side of the generator panel permits monitoring of the voltage output of both inverters. The 26-volt AC available to both the captain's and first officer's flight instruments, and the 26-volt AC available to the engine instruments. The selector switch is normally left in the vertical or 26-volt AC engine instrument position to monitor this voltage. The inverter warning lights will illuminate if flight instrument voltage should fail. 26 volts AC for the captain's and first officer's flight instruments and the engine instruments can be monitored with the three upper positions of the selector switch. The 26 volt AC position on the voltmeter, as shown, is very close to the 0 volts position. Use caution when monitoring these positions, as the meter can be easily misinterpreted. By selecting either the extreme left or right position on the selector switch, the AC output voltage of 115 volts may be monitored for the upper or lower inverter. 115 volt AC reads at approximately mid-scale on the meter. There are only a few basic differences between the AC electrical systems in the Group 1 and Group 2 aircraft. Primarily, all flight instruments are operated from 115 volt AC, thereby eliminating the flight instrument step-down transformers and their associated fuses. As the use of the vacuum pumps are discontinued, we installed 115 volt AC alternators as a source of emergency flight instrument power. Finally, the inverter warning lights were redesignated as flight instrument warning lights, and their associated AC relays made more sensitive or accurate to voltage variations. The Group 2 AC distribution system can be simplified by taking our Group 1 inverter output diagram and modifying it slightly as follows. Adding a pair of alternators and emergency flight instrument switches to connect the alternators to the flight instruments. By deleting the two captain's flight instrument transformers, as well as the one for the first officer and their associated transformer fuses. And finally, renaming and improving the accuracy of the flight instrument warning lights. This now is the basic Group 2 AC electrical distribution system. Inverter output for both the captain's and first officer's flight instruments passes through phase breakers on the throttle lock relay box and through the inverter selector switches identical to the output in the Group 1 aircraft. Prior to going to the flight instruments, power is routed through the emergency flight instrument switch, then to fuses in the AC fuse panel, to the flight instruments themselves. In the event of an electrical failure, the emergency flight instrument switches on the main instrument panel should be moved to the emergency position, thereby using the output of the left and right alternator to power the captain's and first officer's flight instruments respectively. This emergency alternator power can be read on the AC voltmeter when the selector is placed in the captain's or first officer's flight instrument position. The alternators provide AC power to operate the gyros in the flight instruments only. The alternators are mounted on the inboard engines on the left-hand high-speed accessory section of the engine. They are operating any time the engine is running. The alternators are unregulated voltage and frequency AC generators. They will provide 115 volt AC 3-phase 400 cycle power of approximately 100 volt amperes when the engines are operating at 2400 RPM, plus or minus 100 RPM only. At any other engine RPM, the voltage and frequency will vary accordingly. Two flight instrument emergency power switches are located on the main instrument panel, to the left of the captain's and first officer's turn and bank indicator. The switches are a two-position toggle type with a down or normal position and an up or emergency position. In the normal position, inverter output provides 115 volt AC power for the flight instruments. When placed in the emergency position, Power output of the alternators is utilized to power the flight instruments. The metering circuit in the Group 2 aircraft is basically the same as the Group 1, with the exception the captain's and first officer's instrument voltage is now 115 volt AC instead of 26 volts AC. The only 26 volt AC used is for the engine instruments. The AC selector switch and associated AC meter are located on the generator panel in the same location as in the Group 1 aircraft. The voltmeter has been converted to a split-scale meter. Notice that the 115 volt indication is approximately opposite the 26 volt position, to the right of center. The selector switch has been changed slightly by placing the captain's and first officer's instrument position as the last positions of the switch, rather than adjacent to the engine instrument 26 volt AC position. An improved AC failure warning system has been incorporated in the Group 2 aircraft. The inverter warning lights have been renamed Flight Instrument Warning Lights, and the AC relays that will cause the lights to illuminate have been sensitized so that they will indicate an AC power failure when the inverter voltage drops to approximately 100 volts. The Group 1 inverter warning lights required the inverter voltage to drop to approximately 55 to 60 volts in order to illuminate the warning lights. This concludes the DC-6 AC electrical presentation.